Good afternoon, everybody. Welcome to our webinar today on Silica Awareness and OSHA's new final rule. We're excited to have everyone here today. My name is Peter Shackford, Director of Safety and Risk Control for Hendrickson and Associates, and we're presenting this today on behalf of NERCA, Northeast Roofing Contractors Association. Looking forward to hopefully providing some insight on this new final rule, as well as answering maybe some other questions you may have at the end. So let's just start off with what we plan on covering here today during this webinar. We're going to explain briefly kind of what silica is today, what some of the health hazards are. I'm not going to spend a great deal of time on that, as you're here today. I think we hope that those of you who are coming at least have a base knowledge of understanding on what it is and what we're trying to talk about. We'll talk about construction industry and the roofing industry and where we see silica exposure. That's very important, obviously, to be able to implement controls. We have to know where the exposures are first and foremost. So we'll talk about where we find it in construction. We'll get into need for the new regulation. Why the changes? What's some of the background of the regulation we'll talk about, and why OSHA feels it's important to implement this new rule. And then we're going to get into the compliance requirements. Not in the great detail here, but we certainly want to cover the important parts of the new standard, when it's going to be enforced, and what you have to do as an employer to prepare for that, for those dates when they begin to enforce this regulation. So briefly, what is silica? It's a naturally found mineral in the Earth's crust, very abundant, and where we most run across it is in cementitious products and bricks, and in our industry, clay tiles and fiberboards, and anything concrete cement related will have silica content within it. Basically, exposures and health risk related to silica. Silicosis has been the most significant item that's been talked about for many years. But additional health risks such as lung cancer, COPD, kidney, immune system deficiency. So it's more than just the silicosis that we hear at the forefront, that there are some other health risks that sometimes go unnoticed and maybe unrelated to silica exposures, when it's OSHA's belief, in fact, that there is a direct relationship. Where do we see exposures in construction? You see a small list of them here. There are many exposures. Abrasive blasting, such as sand blasting, has been around for a lot of years. Rock drilling, concrete and masonry demolition, construction operations. Earthwork, site work, rock crushing, road construction and repair operations, and within our industry, cementitious products such as tile and siding, fiberboards, cementitious fiberboards, very common to have silica exposures. Just some photographs we see here. Again, some of these are more interior jackhammering and power sanding operations. You can see the plume of dust on the right-hand side, creating a silica exposure. When we say silica exposure, there's a lot of dust we see there, but the concern is the very, very small respirable silica that will then be inhaled and get past some of our protective systems and into our lungs. Here you see a concrete saw cutting operation. You can see the significant amount of dust created, and within that large plume is, again, very small respirable particles, and that's what our main concern is over. Brick and cinder block cutting operations. I'm sure you've all been on construction sites. We've seen things like this. There is a significant difference between operations that are used with engineering controls, such as water here on the left-hand side, versus the operations without it. And that's some of the things we'll talk about here today. This is actually a dry cutting operation. There is somebody within that dust plume, and you're fairly certain that there's an overexposure to silica dust here, and this is what is driving the standard. These type of operations that are going uncontrolled throughout the workplace right now, that have exposed employees for many, many years. We may see some exposures within our industry. Tile cutting you see on the left-hand side, hammer drilling operations on the right-hand side, as well as this cementitious fiber board that gets cut for those of you who might be involved in installing some of these siding and other concrete type operations. Why the need for the new rule? Where's OSHA going with this? Why the need for it? PEL's a permissible exposure limit. That is the limit that we can be exposed to for an 8-hour day. The legal limit that OSHA has devised of silica for an 8-hour day for the rest of our working life, and supposedly not have any long-lasting health effects. This PEL is very old and outdated. Okay, we're talking back 1970s, decades old, and the formulas that they have to use within the construction industry, the equipment needed to calculate and to obtain that data is obsolete and not even really available. Right, so it makes determining what our actual exposure level is very difficult in the construction industry. In addition, they were concerned about the PELs across different industries. They were not the same. So, and most significantly, they didn't feel it was protective. All right, being so old and outdated, it didn't feel it was nearly restrictive enough to protect workers in the workforce from that long-term health effects. It needed to be updated. They wanted to lower it, and they believed they needed to lower it significantly. They also wanted to implement a comprehensive standard, and that's one of the most important parts of this regulation. No longer is it just a PEL that we have to make sure that we're not overexposing the workers to a higher amount of silica. In addition to that, they've added some things such as housekeeping standards, medical surveillance, training requirements to make a much more comprehensive standard for silica exposures. All right, so that's why they felt they needed to do this this new rule, to update those permissible limits to protect the workers, to make them so that they're easier to obtain, and as well as to implement this comprehensive standard, which is going to require, we'll get into a lot of the requirements of it, but the medical surveillance piece and additional training requirements and written programs, much more than just having a permissible exposure limit. With any of these new rules, OSHA has to do a benefit analysis, and they provide some information out there as far as some of the health benefits anyway here. They believe that this standard, implemented fully, will protect and prevent 600 fatalities annually, prevent more than 900 new silicosis cases annually. So these are some of the numbers and statistics that they've come up with, and their belief that the benefits of this new rule will create. So as we get into the new rule, and we want to discuss compliance, the first thing that I like to kind of talk about is let you know as far as when. All right, this is kind of timely. Today, June 22nd. Actually, tomorrow, this rule actually becomes effective. All right, but don't get alarmed. Even though the rule is being effective as of tomorrow, there is a full year that they're permitting companies to get into compliance, full compliance with this requirement. The enforcement does not begin until June 23rd of 2017. Now, just to caution everybody here, it doesn't mean that we could ignore it. There are a number of things that we'll talk about here today that need to be done over the next year to prepare ourselves to be in full compliance come June 23rd, 2017. In addition, we still don't want to overexpose our employees to silica dust and harmful health effects related to that. So, and there are still some other avenues if we completely ignore this that OSHA could pursue for, for enforcement of citations, such as the general duty clause, hazard communication standards, etc. So we still need to protect our workers, but as far as this new rule and the compliance requirements of this rule, we have a year to fully implement those. So let's kind of talk about what some of those requirements are. First thing with any regulation that OSHA mentions is the scope, the application, who it applies to. And this is going to apply to all occupation exposures to respirable crystalline silica. Again, those small particles of silica that can get into our lungs and cause those negative health effects. In the construction industry, except where they're exposed to below 25 micrograms per cubic meter of air as an 8-hour time-weighted average. So that's an action level that OSHA has implemented. All right, so what is that? We need to first determine where our silica exposures are, and You know, if we see a dust plume, if we have concrete dust, cementitious dust that we're creating, we either have to make sure through air sampling that they're below that 25 micrograms per cubic meter of air, or assume that they are and implement one of the controls that they have in place here and that they're going to discuss that we'll review. So that's the scope and application. This is going to apply to all construction workers exposed to any types of silica in the workplace. And being so prevalent, this is going to affect everybody across the industry. So how do we comply? We have an operation that we believe creates silica dust. Again, we have to either make sure that it's below that 25 micrograms per cubic meter by performing sampling, or we'll get more into that. They provide what's called Table 1. This is the first option to comply with the regulations. And OSHA strongly believes that this is the option that the vast majority of employers are going to go with. All right. In the past, the prior regulations, even when we had equipment that would create engineering controls to keep dust down, there was still a need to perform sampling to make sure that that equipment was effective in keeping the dust down below that permissible exposure limit. Now, mind you, the new permissible exposure limit is much, much lower than it was prior. However, OSHA has already done the background, the research for us, and included it here in Table 1. So if we comply with Table 1, and we'll go over here in a bit, it lists a number of tasks that are very common in the industry and a number of required control mechanisms. And if we implement all those control mechanisms for each of those tasks, there is no need to perform air sampling, no need to comply with the Pell, because it is their finding that those controls are already effective in keeping it below that 25 micrograms per cubic meter, and therefore rendering compliance. So what does that all mean? Let's take a look at Table 1. All right, this is one of a number of pages that OSHA has provided within the regulation that details specific tasks that are being performed that create silica exposures. You'll see the first one here, the stationary masonry saws. Okay, they have engineering controls that they have listed that can effectively reduce exposures to below that action level here. And they also list the length of time that the employees are performing those tasks. So here on the right-hand side, using the stationary masonry saw, cutting any type of cementitious product that creates silica exposures. As long as we use a saw that's equipped with an integrated water delivery system and operate that tool in accordance with the manufacturer's instructions, you'll see on the right-hand side there is no need for any type of respiratory protection, whether it's less than 4 hours or greater than 4 hours for performing that task. Right, and that's the way that this table is set up. They list a number of tasks. One of them you see on the bottom here might involve some of our roofing operations, or some roofing companies in here might be involved with, I should say. You see the handheld power saws for cutting fiber cement boards. A number of contractors who are involved in roofing work will also perform some siding operations, and sometimes deal with these hardy boards, these cementitious fiber boards. And you'll notice here some of their controls here. It says right here for cutting fiber boards with a blade diameter of 8 inches or less, so a smaller diameter blade. It mentions for outdoor tasks only. It'll allow you to use a saw that's equipped with a dust collection system, operate it in compliance with the manufacturer's instruction, and the dust collecting system must be maintained properly. If those things are in place for outdoor operations, there is no requirement for respiratory protection. So utilizing this table, if you had a saw that was less than 8 inches in diameter cutting these fiber boards with these controls in place, you're already in compliance, okay, with this part of the regulation here. No need for air sampling or respiratory protection. Okay, there's a number of engineering controls as a part of any type of exposures to harmful chemicals. The first thing we want to do is try to engineer things out. So I've put these photographs in here because OSHA would prefer that the first thing we do is engineer out the dust control, the dust exposure. For cutting concrete fiber boards and things like that, there are a number of devices now on the market, such as this I see on top, this handheld shear, and on the bottom left you have these power scissors here that reduce the dust down to nothing. Okay, very little dust, very little exposures. These are even more preferred so than trying to go ahead and utilize those saws that were mentioned prior, those power saws when cutting some of these type of products. You see here an example on the left-hand side. He's using a circular saw to cut those fiber boards, and on the right-hand side he's using the power scissors. And you see that there is no dust accumulation. So the first thing that we should look at when we're talking about these type of exposures is, can we engineer out the hazard? And kind of in the hierarchy of controls, that's what OSHA would like us to do. As we look further into Table 1, some other operations of other tasks that they have listed in here, I've broken out for you and pulled some of them out. On the bottom, you see the handheld grinders for uses other than mortar removal. Roofing contractors at that time may use handheld grinders to grind concrete surfaces. In doing so, that's going to obviously create dust. So again, for tasks that are performed outdoors only, you see it in the middle column under their engineering and work practice controls. If they utilize a grinder equipped with integrated water delivery system that continuously feeds water to the grinding surface and operate that tool in accordance with the manufacturer's instructions, there is no requirement for respiratory protection or ear sampling. Again, if you implement those controls, you are in compliance with this part of the regulation, and there is no overexposure. I'm sorry, using that handheld grinder, the other operation for handheld grinders for uses other than mortar removal, if you use a grinder that's equipped with a dust collecting system and operate that in accordance with the manufacturer's instruction. When used outdoors, there is no requirement for respiratory protection. However, notice if you're using it indoors for some reason, if it's less than 4 hours, there is no requirement, but over 4 hours, then you will need a respirator with an assigned protection factor of 10. Okay, so I just wanted to break that out. It's an operation that sometimes roofing contractors may perform, is grinding of concrete, and there you see a situation where less than 4 hours indoors, they would not require any type of respiratory protection, providing that dust collection system was in place. However, there are times if we go over that 4-hour limit where they're going to require respiratory protection. Again, no ear sampling is needed here. I provided just, we don't see these often, but there are the tools that they require to be used are available on the market. On the left-hand side is a grinder which has a water delivery system. On the right-hand side, we have another angle grinder here that has a dust shroud and the dust collection system that they require. So, again, they're controls that they've requested and required to comply with Table 1. There are tools on the market that can be utilized to meet those needs. So I'm not going to go through all of Table 1 here for you today, but these are all the operations that they list out within Table 1. It is the belief of OSHA that majority of contractors are going to choose Table 1 versus obviously going the air monitoring route, which we'll talk about here in just a second. If they can find an operation that is listed within here, they believe most of these operations here are going to encompass the vast majority of silica creating operations in the workplace. So they're hoping that the controls that are listed in here are going to be implemented and thus eliminating the silica exposure to these workers. So in addition, regarding Table 1, there are some things that we need to be aware of if we're going to use Table 1 as our option. If any task is performed indoors, a lot of Table 1 will mention indoor operations and list controls for those indoor operations. If they're going to be done indoors, their concern is accumulated dust. There's got to be some type of exhaust system within the facility to pull that dust out of the building so we don't have it accumulating. As the dust settles, as it accumulates, it can get kicked up later and create an airborne hazard. So they want to have an exhaust system within it. And if we're using wet methods, they specifically mention that the flow rates need to be sufficient. Here you see a photograph. I took that photograph many years ago of an employee using a wet saw, cutting concrete block, and the water system just wasn't working properly. All right, so we need to make sure that any wet method is going to minimize the release of any visible dust. This is fairly significant, maybe not for the roofing industry here, but a number of the tasks in Table 1 involve heavy equipment, and a control mechanism is to just close the door, or have an enclosed cab. Here you see a whole ram operation. Creates this rock, this silica content, creates a silica exposure that's airborne. So during this whole ramming operation, one of the control mechanisms is that they have an enclosed cab. However, if you're going to have this enclosed cab as a control mechanism, they list a number of things that have to be in place. It's got to be maintained as free as practical from any settled dust, so they're going to have to clean it, maintain it, keep dust from accumulating inside the cab. It needs to have doors that seal properly, and you know, there may need some maintenance on that. So gaskets and seals that are working in proper condition under a positive pressure, has an intake air filter that's 95% efficient, and has heating and cooling capabilities. Obviously, they're concerned about you know, climate within these cabs as they're enclosed. So they specifically went as far to mention those requirements if they're going to use those enclosed cabs as a means of protection. Finally, in regards to Table 1, some employees may be performing multiple tasks that are within Table 1. So you know, OSHA tried to take this into account, and if the total duration of all the tasks that are being done is greater than 4 hours, then each task needs to have the protection specified for more than 4 hours per shift. Okay, so even if they're doing 2 hours of one particular task and 2 hours of another, 2 hours of another task, a total of 6 hours, we can't take each task and utilize the under 4 hours exposure control. We have to utilize it in each task as if they're exposed for greater than 4 hours. They're looking at the accumulation of the silica exposure that employee may be exposed to. So that's something that we need to be aware of and calculate for as we evaluate our employees' exposures. So that was Table 1. That's Option 1. That's the one, again, that OSHA believes the vast majority of contractors are going to implement. If the task that you're performing, however, is not anywhere on Table 1, or for some reason you decide not to use Table 1, they do have a couple other things that can be performed through the alternative exposure control methods. I don't want to get too technical and too much in detail here, but what this involves, the first one, basically we want to make sure that the employees are not exposed above their new exposure limit of 50 micrograms per cubic meter over an 8-hour time-weighted average. Okay, so we need to assess the workplace and make sure that we're not going to be overexposed to that. So how do we do that? What they allow is two different control options. Number one is a performance option. And what this is you can use a combination of any monitoring, air monitoring results that you've obtained, or any objective data from the industry to accurately characterize the employee's exposure. Coming up with objective data from maybe other industry sources, some air monitoring that you may have conducted or obtained elsewhere, something to show that these employees are not exposed above that 50 micrograms per cubic meter. The performance option is up on you to come up with a method to affirm that. Okay. The second option that they have is a scheduled monitoring option, and they list. I'm not going to go into great detail in the frequency of the testing and things like that, but they do have a schedule that they've developed within the regulation, which is going to permit you to do air sampling, and when air sampling is going to be required to be conducted in the future, depending upon the results of that initial monitoring. So again, if we're not going to use Table 1, basically the other option then is we need some type of air monitoring results. Either we use some objective data that can verify that our employees are not overexposed, or conduct air sampling per the scheduled monitoring option that OSHA has within the regulation. So what all the contractors here in this room need to kind of determine over the next year is where their exposures are, where do they fit into Table 1, if they fit into Table 1, can they implement those effective controls as required, and if not, if they're going to use this air sampling, come up with that data, be it objective somewhere throughout the industry, or use that scheduled monitoring option and conduct some air sampling within your own companies to ensure, to at least initially determine what the exposure levels are. If we're doing that air sampling, the exposure assessment, OSHA has set forth in the regulation the requirement to notify employees within 5 days of the results. These have to be given in writing to the employees or posted in a location that's accessible to all employees. So they want to have that communication. These are the sampling results, and make sure the employees are made aware of them. If the exposure assessment comes above the PEL, you've done the air sampling and they're above that 50 micrograms per cubic meter, you've got to describe, in addition to that notification, what type of controls you're going to implement. And it also requires that you, the employer, provide effective employees or their representatives the opportunity to observe the monitoring. So in union environments, the steward on the project or another representative needs to be offered the opportunity to observe the monitoring while it's taking place. As stated prior, they do, and they have mentioned throughout the regulation, the need, the importance of the hierarchy of controls. Basically, what they want us to do first and foremost, after we conduct our air sampling, is try to eliminate it by using sound engineering controls. We talked about water, dust collection systems, etc., prior to PPE. As a last resort, they want us to put employees into respirators. So the first thing we should try to do is get those exposure levels down as low as possible, and if we can't get down below the permissible limit, that's when we go to personal protective equipment as a last resort. Mind you that implementing a respiratory protection program is required if you're going to require respirators be worn because they're above any permissible limit. So along with this standard, at that point you're going to get into the respiratory protection standard and all those requirements. They have some additional requirements within the regulations, focusing heavily anyways on dry sweeping and compressed air being used to blow concrete off of basically as a cleaning and housekeeping operation. So we want to avoid that dry sweeping and use of compressed air. Right, they're requiring other controls be done, other things be done, such as sweeping compounds and vacuums and water misting and things like that to keep dust from accumulating in the air. The regulations specifically discuss some of those controls. And they also are going to require us now, once we've done all this evaluations, to have a written exposure control plan. Our employers need to establish and implement the control plan that is basically going to do a lot of things that we've already talked about. It's going to provide a description of all the tasks that are in your workplace that are going to involve exposure of silica to your employees. So it's kind of like a JHA. You're going to list the engineering controls for each of those tasks. They want you specifically to talk about those housekeeping measures. How do we need to sweep? How are we going to avoid dry sweeping? What are we going to do to keep those accumulated dust that are on the ground from becoming airborne by sweeping? And a description of procedures used to restrict access to work areas when necessary to minimize the number of exposed employees. So if you have operations where respirators are being worn because of an overexposure to the silica dust that can't be controlled otherwise, there needs to be a means to restrict others from entering that area. So they want that discussed in the plan. They want the plan to be reviewed and updated on an annual basis, be available to employees, and they specifically mention a competent person that must be designated to perform frequent regular inspections of other work area during these operations to make sure that these controls are being properly implemented and all these items are in place. The standard does set forth a requirement for medical surveillance, and it's only required in the standard for each employee who's required to wear a respirator for 30 or more days per year. Again, another reason to try to avoid and engineer these hazards out so we don't have these employees having to wear respiratory protection. But if they're going to be wearing respirators for 30 days or more because of the uncontrolled silica exposure, we'll need to have a medical surveillance program for each of those employees. The regulation goes into detail exactly what that surveillance program is, and having what kind of professionals need to evaluate them, and having the pulmonary chest X-rays, etc. Goes into much more detail. I didn't get into a lot of detail here today, but realize again, if we're going to have employees who are exposed to these kind of hazards and wearing respirators for 30 days or more per year, this is something we're going to get into. We're going to have to dive a little more deeper to. They specifically mention our hazard communication standard within a regulation. They want the new standard mandates for employers to put silica into their program and in their training. So you have to have safety data sheets relaying silica exposures, make them available for employees, provide some training on the hazards of silica dust in the workplace, and again, what controls you require. Most of those should be addressed through your exposure control plan we discussed prior. Again, getting into the employee training requirements, the employers must ensure that employees can demonstrate knowledge and an understanding of the following. And this is a little bit significant, something different than OSHA has done in some of their recent regulations they've put out. More than just providing training, a lecture, talking to the employees, the employer must ensure that the employees can demonstrate knowledge and understanding. All right, so this needs to be there needs to be some other method to than just presenting it to them. We need to make sure that they understand it. That can be done through tests, through hands-on evaluations. Those considerations should be made. The things that they need to be able to demonstrate knowledge and understanding and include the health hazards, the specific tasks that could result in the exposure. So what are we doing in the workplace that causes a silica exposure? They have to have knowledge and understanding of that. The specific measures that are required to protect the employees. The content of this section, so they want them to have knowledge and understanding of the regulation and the requirements of the regulation. So we need to train them on the standard and again make sure they understand at least the key components of it. They have to know who the competent person is. This is important. I do a lot of inspections within the industry, and very often we ask employees, who's your competent person? Based upon the exposure here that requires a competent person, and they don't know they don't have an answer for that. They don't know who that is. Specifically in the standard here, OSHA is requiring that the employees know the identity of who that competent person is. And in addition to this, the purpose and description of the medical surveillance program. If there's a need for a medical surveillance program, the employees, of course, need to understand why, the importance of it, and kind of what it is going to encompass. So I actually did a quick overview of a number of the regulations here. I wanted to make sure I introduced you to Table 1. There are a lot of additional resources that you could obtain. Now there's a Silica e-tool that they have available. The silicasafe.org website is great. In fact, they have a lot of information on there on how to create your own plan, kind of a JHA for each of your exposures. The CDC has a lot of great information there as well. Just to quickly summarize some of the things we went over here, and again, make sure that we understand what we need to do within that next year to get into compliance and prepare for this new regulation. It goes into effect, again, July 23rd of 2017. You need to begin evaluating your exposures, right, seeing where they fit in within Table 1, and if they don't, or if for whatever reason you can't implement the necessary controls that are required within Table 1, we're then going to have to start creating that objective data, right, or air sampling, performing that air sampling to determine where our levels are and what kind of controls we need in place. So that needs to be done before. We can't wait till after July 23rd, 17 to start doing air sampling. And that's the part that I want to make sure that everybody understands. We need to have these controls in place and implemented on day 1, July 23rd, 2017. If we're using that Table 1, again, making sure that we're implementing those controls and that we have the tools and the training and the wherewithal to do so. We're going to need to start developing that exposure control plan. We covered that a little bit here, listing everything, all of our exposures in the workplace, what our controls are going to be. And then finally, we need to provide training for our employees as detailed above, and having a means for them to demonstrate. A great way to do this would be Number one, some type of written test, and then try and implement some type of evaluation in the field if you have employees who are actually doing some of these operations and you put the controls in place, doing a field evaluation to make sure that they understand and are implementing those controls effectively would be a great way to comply with that portion of the standard. Okay, so we got through this portion of the webinar here today. Covered the key components of the standard. Got through it actually a little quicker than I thought we would here, but I think we covered the important parts of it here today, and I hope you all took something from it, learned something from it, and have a better understanding of what the new regulations are and new requirements are going to be here. And I'm going to stick around for a few minutes prior for a Q&A. I'll unmute everybody here in just a second. I'm going to close the recording as this is going to conclude our webinar portion. And I thank you all for attending, and I look forward to seeing you in future NERCA webinars.